Okay, good afternoon, everyone. Today I will be presenting end-to-end detection and pose estimation of two interacting hands from ICCV 2021. This is paper of our lab mate who graduated 2 years ago. And this is my first paper about hand poses. I will make a lot of mistakes, sorry. Sorry in advance. Okay, for 3D hand pose estimation, like it's determining 3D coordinates of the key points of hands from the image or videos. And like its application is for augmented virtual reality, sign language recognition, and other gesture-based user interface. And there is some challenges on this task, such as like occlusion, especially when two hands are interacting, or obviously one of them will occlude the other one. And it's making it difficult for detecting the other hands key points, and also the complex configurations. Interacting hand can take on numerous configuration. Yeah, like they can the interaction can be a lot of things, and then also the physical plausibility. Sometimes the model detects, and then when you visualize it, you will get some kind of like intersecting fingers or something, which is not physically possible. So this is like the challenge on 3D pose estimation. And then objective of this framework is, so in this work, they try to simultaneously train the detection and pose estimation at the same time. And they use GAN type discriminator to solve the physical plausibility issue. This one, and then also the final model is like detection and pose estimation, like into a single end-to-end model, trainable model. So yeah, so recently like a CNN-based approach for 3D hand pose estimation are becoming very popular, but the problem is that there is not enough training data. So like there is some several data sets such as like this Sionas, Pego 3D and Interhand. But the thing is that like when you want your model focused onto interaction, there is very few interacting scenes on these data sets. Even though like this Interhand, it has like million scale real image. But when you just focus on interacting hands, and like this IO score bigger than 0.5 means that like intersection or union of both hands bounding box is bigger than 0.5, like they're really interacting. And then the number of the image reduced to just 18,000. So this is this is like some limitations. So in this paper, they propose like CNN-based pose estimator framework, and then they train it on existing data set, the mentioned data sets. And then the result of this method is like state of the art on single hand pose estimation and both like interacting hands. So they build their methods upon the hypothesis that like they just, in case of interaction, like usually one hand is occlude the other one. So they said like they say that like the visible hand contains like very useful information for inferring the pose of occluded hand. And they do some experiment to validate this via statistical tests. And also their framework like uses these dependencies to like estimate the pose of occluded hand. And also like additionally, they explore the structural dependency of two hands by training GAN type discriminator. Like this GAN type discriminator helps them avoid physical implausible joint hand configurations. And yeah, the visibility of each joints are exploited and used to improve 2D pose estimations. Yeah, so we'll talk about this a little bit later. And then the architecture. So in the architecture, they have like hand detection network, and then which detects and classifies the hands into interacting and non-interacting categories. Okay, they do this one for further reason, talk about it also later, and so yeah, so using this framework, they achieve. I mean, yeah, first they do the classification, and then they do pose estimation depending on which type of is it like interacting or not interacting, and they do pose estimation depending on this one. And so like using this approach, they tailored hand pose estimation system for challenging cases of interacting hands. And also like as we mentioned earlier, they also like retain the state-of-the-art performance single hand cases. And also like their model is trainable end to end. Okay, so here is some example of the proposed method and the like results. So this first row is a result from the previous state-of-the-art model. And then this is the results from their method in the second row. As you can see, like there is huge difference. And then since like their method focuses on if the each hands are interacting or not, so it gives much better result. And also they like visualize their key points, and then like there is this yellow one are occluded key points, and then the rest is like visible key points, and also like 3D view of them. Yeah. So this is the overview of the architecture. First, they have like input image, and then they have like feature extraction, and then they have hand proposal network, and then they have ROI feature pooling, and then they have hand classification and block generation. So this ROI pooling also detects the bounding boxes, but this hand classification and bounding box generator, this one kind of refines it, and then yeah, so and then like the results would be like separate or interacting hands, and then it goes through this whole other procedure, and then the final thing would be like estimated 3D skeleton. So we talk about all of each these concepts one by one. So yeah, end-to-end detection of pose estimation and interacting hands. So the problem definition, like yeah, the final idea is to generate 3D joint positions of hands within RGB image. Yeah, so like in their experiment, they just focus on they assume that only single person is in the image, and then they focus on that one, but their method also works for multiple person. And yeah, so also another thing is the motivation is that when like hands are interacting, they are occluded, but as we mentioned earlier, the visible hand also like gives a lot of information about the occluded hand. Yeah, so this is like they did this experiment, dependency of interacting hands, and then yeah, they through this like Hilbert's niche independence criterion, they find that like the dependency of occluded hand on the visible hand is very high, and when they apply the same thing on the non-interacting hand, the results are much lower, which means that like yeah, it makes sense. So I'm not sure about how to do this experiment or thing, but yeah. So through this like kind of statistical experiment, they show their motivation. Yeah, so overview of the network. This is the statistical dependency of closely interacting hands. Yeah, so like first they get like features, and then they use those early stage features in the later on the architecture. So okay, we talk about this like later on. So yeah, so the network consists of the detector and the pose estimator. But here, yeah, the first part is detection, and the second part is pose estimation. So the hand detector receives an input image, and then it generates like this dimensional feature maps of localized hands. and their handedness. So this is like, is it left hand, right hand, or interacting hand? And so for in the case of the interacting hand jointly, in case of interacting hand, the pose estimation estimates like all of the key points together, and in the when they are not interacting, then for they like poses, 3D poses are estimated separately. So let's go deeper into detection network. Yeah, hand detection combines so the first the image goes through the feature extraction and then go to into the proposal, and then they have like ROI pooling and box generator, hand classification and box generation network. Yeah, so for detection, they like kind of adopt faster approach, representing object bounding box proposal based on the anchor boxes and different aspect ratio reference. Yeah, so like first they have like feature extractor, and they use this loss for minimizing the. This loss is used for feature extraction. So yeah, when for like hand classification and box generations, they generate like a bounding box by selecting the proposed bounding boxes, and then they separate those into like a left hand or interacting and also background. Sometimes a proposed bounding box is empty, so this is like classified as a background. And so this is the loss function they use for this network. And also here, they use this value for like if this threshold, and if the like IOU of two bounding box is larger than this threshold, then they classify it as interacting. And they said like this is very important because if we make this value very large, then many traces from the data set will be categorized under interacting. So, but if you make it smaller, then the few images will be categorized as interacting. So this kind of determines the size of the interacting data set. So they for training, they use 0.3, and for testing, I think they use 0.5. And they say like this is good trade-off for training, and also like both proposed network and this FCB predict bounding box location and their classes. So yeah, so the main idea for this CB is that like this hand proposal, it kind of proposes a lot of bounding boxes and classes, and the main idea behind this one is just to refine them, and then like and the output from this is just left hand, right hand, or interacting. So it kind of this one maybe propose some like background, but this second one doesn't. It just separates left hand or interacting, and they remove the other unnecessary bounding boxes. And in case of pose estimation, it consists of two subnetworks, which like, yeah, as we said, the first detection divides them into single or interacting, and then they have like two subnetwork of pose estimation, one for single and the other one is for interacting hands. And yeah, for single hand 3D pose estimation network, it combines 2D heat map estimator and 3D depth value estimator. So like there is more information about how it works. So it takes the heat map estimator, converts the input feature map to 2D heat map size of 28 by 28. And this is like, here's the J is the number of the key points, and they use like 21 key points. So the output is just 21 by 28 by 28, the heat map of each key point. And then it's fed into depth estimator. And so this is like single hand 3D pose. So for like this process will be done for left, right hand separately. And then the output, and then the result of this is just 3D key points. And then for like interacting hand pose estimation, it's the same process, but it's done only once, and they make use of like joint visibility estimator. So this will kind of guide for like here for interacting, they do 2D heat map estimation, and they also do joint visibility estimator, which kind of like estimates which key points are visible and which are not. And then they use this value and enhance this detected 2D heat maps. So they get like much better heat maps for key points because of occlusion. They don't do this one in the single one because there's no occlusion, but in the interacting, this is like, this is used. And then, yeah, and then they like 3D depth estimator network. So like there's more information about it, about losses. So, and after like they get refined 2D heat maps, they get 3D key points. And yeah, so interacting hand pose discriminator. So like while training the hand pose estimation jointly on interacting hand. And yeah, as we said earlier, like sometimes the results of like just detecting 3D key points are like like this first image, for example, they propose something which are not physically possible. So they solve this by capturing the structural dependency via GAN type joint hand pose discriminator. So yeah, they decompose into this discriminator consists of two discriminators. The heat map discriminator differentiates the real heat map from those synthetic, and then the 3D pose discriminator distinguish real 3D skeleton from estimated ones, constructed by combining M and Z is a features in like inside the model somewhere. And so the discriminator sees the entire 3D joint instead of only depth part. And then like they said, this one, when like you put entire 3D joints into discriminator, this like provides a better context. But when you give just only depth, it's not enough to check the realism. So, and then like, as you can see here, the first one is without discriminator, and the second one is when they use this discriminator, and the last one is ground truth. And then as we can see, when they use the discriminator, it's much closer to ground truth, the visualization. There's still some like some misdetection, but it's much better than this one. Oh yeah, so here's some like details about the data they use. So they use the data from these three data sets that go 3D. And yeah, so that for training 50,000 and for testing 5,000. And then annotation on this data set is 3D ground truth of 21 skeletal joints. Yeah. And then for interhand 2.6M, this is realistic data set with RGB and 3D pose annotation of two hand interaction. It has much more image than previous one. And for this one, yeah, I'm not sure familiar with this data set. So yeah, they use like for testing, they use this for this data set only for testing. Yeah, for there is several like baseline results on these data sets. So they compared their method results, and here like some evaluation metrics. They have like 3D EPE, and then they have 2D EPE. So 3D is for 3D key points, and 2D is for 2D. And then yeah. So here like this Ego 3D data set uses 3D EPE, and Interhand uses MEP, JP, this evaluation metrics. Here, so the results. So they say that like in case of 3D, in case of 2D, they just project their like their 3D onto the image, and then they get their 2D. I mean 2D key points, and then like they achieve like state of the art in almost all of categories. And this is some like visualization of their methods. So, and also lastly, they perform some like ablation study, and they wanted to see how much each of their components affect their overall results. So yeah, like they have two type of testing, like the entire data set and only interacting hands. And here LD, shit, I don't know what comes this. LD, I think the LD is from detection, interacting classes, interaction. I think yeah, this case it's like they do detection and separate each like into single or interacting hands, and then if they don't do this, the result is this one. But when they put everything together, they get like the best result of separation detection. Oh, yeah, this is for me. If you have any question, I can send you the paper.